Welcome back to the last and final video for session 3 on 17.1 thermochemistry, and then we're going to talk about types of heat transfer here. So for a lot of you guys, this will be a review from middle school. So there's 3 main types of heat transfer that we study here. So the first one is conduction, which is the transfer of heat through direct contact between objects. So that's represented down here in this picture, where the ground heats up the air. Second one is radiation. It's the transfer of heat as electromagnetic waves through vacuum or matter. And then last but not least, we have convection, which is the transfer of heat through the movement of fluid matter. So on the next few slides, we're going to talk about scenarios of each one and why does each one occur. So first one is conduction. So conduction only occurs through direct contact. And this is because the particles have to be able to collide into each other. So once again, going back to that KMT model of matter, that everything's made up of tiny little particles. It can be atoms, it can be molecules, and each particle will have kinetic energy. So a reminder of that definition, the temperature of an object corresponds to the average Ke, or moving energy of an object. So when particles bump into each other, the warmer particles will transfer some of their Ke to the neighboring colder particles. So we look at this image right here, we have a metal stick in the flame. So the flame is heating up the particles inside the stick, and the one that is directly above the flame is going to be moving a lot faster. However, that particle that is in place in the metal stick is going to smack into the neighboring particles and transfer some of its energy to that neighboring colder particle. Well, that neighboring colder particle will also transfer to also another neighboring even colder particle. So it's kind of like that hot potato scenario going on again, where the heat is being transferred away from this when the source of the heat, the flame, so it spreads until it gets to the point where it reaches the hand. So at thermodynamic equilibrium, the particles will roughly have the same amount of Ke. And that's the point whenever the heat stops flowing from the tip of the stick all the way to the hand. Our next scenario here is radiation. So once again, we're going to redefine electromagnetic radiation. These are waves that can travel through matter and space. So space, we're talking about outer space, that is a vacuum where there's no matter. So when the objects that do absorb the electromagnetic radiation, it's gonna transform that energy into heat. So the best example we have is right here in our homes. Microwave ovens produce electromagnetic waves that are in the microwave spectrum. That's anywhere between 1 millimeter in wavelength all the way up to 1 meter in wavelength. So those microwaves that's being produced by the oven is absorbed by the food, and then when the food absorbs it, it's going to increase in vibration. And that increase in vibration, increase in kinetic energy, that's heat for you guys. So that moving molecules is what heats up your food. Second scenario we have is nuclear radiation. So nuclear reactions in the sun produce solar radiation. So solar radiation is actually a huge spectrum of electromagnetic waves. It can be anywhere from a strong gamma rays, which is what's used in X-rays and so on, all the way down to visible light, and also some UV light. So they tell you to put on sunscreen because that is a form of radiation that's coming from the sun. So that solar radiation that's happening on the sun is going to travel through outer space, that vacuum, before it hits our atmosphere. And when it hits our atmosphere, it's also going to be absorbed by some of the air particles, but most of it is going to be absorbed on the surface of the earth by the oceans. Just an FYI, 71% of our earth is covered in water. So most of that energy is going to be absorbed by water. And we talked about heat capacity earlier, right? Water can absorb a lot of that energy. So the reason why our Earth is livable is because of solar energy, solar radiation from the sun warming up our Earth, and that ocean stores a lot of heat and releases it back out to warm up our Earth. So the temperature is going to be relatively constant. It's not going to change too much. We can live here, whereas on Mars or on Venus, the temperatures are so dramatically different, we cannot survive there. And last but not least, we have convection heating. So this is whenever fluid, so fluid is defined as any matter with particles that can move very freely, such as liquids, gases, as well as plasma. So those are the ones that can slip and slide around each other. So whenever fluids are heated, the particles are free to move around more vigorously, and not only are they going to shake around a little more and slide past each other, they're going to also move further apart. So going back to KMT, whenever things have more kinetic energy, there's going to be more space between the particles. But whenever you have the same amount of particles in a system, but the space becomes bigger between your particles, the volume goes up. So fixed mass volume goes up. The density is going to decrease as temperature increases. So that difference in temperature, in density and temperature will create something called a convection current. So convection currents describes whenever warmer, less dense fluids rise to the top, whereas cooler, denser fluids will sink to the bottom. So looking at the image we have up here in the upper right, whenever you have water on a burner, the burner is super hot. That could be like thousands of degrees in Fahrenheit, whereas the air is going to be at room temperature, maybe 65 degrees Fahrenheit. So you have hot water closer to the burner at the bottom of your pot rising up because it is less dense than the water at the top. The water at the top is closer to your room temperature air. So since it is colder, it's going to try to sink down, and it's going to cause the currents so that the water is always cycling inside your boiling pot of water. So if you ever put spaghetti in it and it starts to move, it's because of those convection currents. It's also responsible for a lot of the natural phenomena that happens on Earth. So we have moving tectonic plates on our Earth. So why we have earthquakes as well as volcanic eruptions is because of convections. You got the hot liquid mantle, that's molten rock underneath the crust. The crust is the coldest portion, whereas the inner core is responsible for heating up the mantle. The warmer mantle, the warmer rock is going to try to push up towards the crust, whereas cooler mantle is going to try to slip down. And it's going to cause these cycles underneath the crust of our Earth, and it's going to start pulling at the crust, causing those earthquakes as well as volcanic eruptions. We also have wind. Wind is also due to convection currents. You have colder air up top. So when you're in an airplane, it tends to be colder because outer space is really, really cold. And then air that is our atmosphere that is closer to the ground, to the surface, is going to be warmer because there's a lot of conduction heating. So the warm air is going to be closer to the ground where you have sand as well as the ocean releasing heat directly to the air particles. So that warmer air wants to go up top, and then the cooler air wants to sink down. And that's going to create our winds. And last but not least, ocean currents. So the reason why we have waves, hurricanes, and tsunamis is because of convection heating. Some parts of the Earth is warmer than others. So remember that if you're closer to the equator, it's going to be warmer than your poles. Well, that warm water wants to travel to the top, and cold air wants to slip to the bottom. That's going to create currents. So if you have a slipstream and so on, it's because of the fact that your cold water wants to slip down, warm water wants to slip up. It's going to create currents as well as waves, and that can create crazy things like hurricanes and tsunamis. So this is something for you guys to think about, some food for thought. Whenever you increase heat, when you're boiling a pot of water, it boils more rapidly. It's going to move a lot more. So what's going to happen whenever we have climate change and the Earth is getting warmer? What's going to happen to our weather patterns on Earth? Let's think about that in terms of convection. And that's it. So what we have for you now is that we're going to have 2 assignments for this week for you guys to find on Google Classroom. The first one, since we just finished our video, is some practice problems. We have 10 multiple choice questions. It's going to be called thermochemistry practice problems. Go ahead and answer those questions and check your answers. So it's just trying to see what you got from this video. And it's going to give you some feedback. When you're done doing that problem, check the feedback, see what you know and don't know. You can look at some of our supplemental activities if you didn't think you got something better. That's going to be on the next slide. We got a bunch of links for you. And then when you are ready, before the end of Sunday, that's going to be 426. You do have an exit card. You're going to have 5 questions on Google Forms for you guys to do for accuracy. So this form, you can change your answers up until Sunday, 426. However, remember, after 426, after the due date, you can't change the answers anymore. We grade what you have for accuracy. If you have any questions, please stop by our office hours. Thank you.